All right, in this video, we are going to kind of take a step farther from just plotting some points, and we are going to have an equation. And with this equation, we're going to make a table of solutions for the equations. Okay, um, so basically what that means is we are going to plug in x's and get y's out of them. And those are solutions, those are coordinates. So here's what we got. So we're going to make a table. All right, we're going to do some math. So there's kind of a general 5 points that I like to plug in to create this. So I have this equation, and this equation is going to have some graph. And so I'm trying to figure out, what does this graph look like? And so what I'm going to do is I'm going to plot a bunch of points to get myself an idea what this graph looks like. Okay, so here we are plugging in. Here's kind of our generic 5. We're going to plug in a -2, -1, a 0, a 1, and a 2. Those are kind of my generic 5 that I always just plug in. I like to plug in a couple negatives and a couple positives and a 0, because negatives sometimes have a different effect than positives. And so we've got to sample each kind of group. So I don't know what I'm going to get when I get a y out of it for the y. So what I'm going to do is I'm going to be substituting that x with the -2, plug it in, do the math, and let's see what we get as a y value. Okay, so here's our math. So 2 times -2 minus 3, and then we're going to do 2 times -1 minus 3. We're going to do 2 times 0 minus 3. We're going to do 2 times 1 minus 3. And we're going to do 2 times 2 minus 3. Okay, so that's the math that we're about to do. So 2 times -2 is -4. -4 minus 3 equals -7. So when we plugged in a -2, we got out a -7. So x is an input, y is an output. Okay. If we plug in a -1, 2 times -1 is -2. -2 minus 3 is -5. Okay. If we plug in a 0, 0 is a good one. 2 times 0 is 0. 0 minus 3 is -3. Okay, now very often there's a pattern that's happening. And it's nice if we can recognize it, and we're going to see if we can just kind of add to the pattern, and then we'll kind of verify that that pattern did what it was supposed to do. So if you go, so these are all going up by 1s. This is going from a -7 to a -5 to a -3. We're going up by 2. So this next one should be a -1 and then a +1. All right, let me double check. So 2 times 1 is 2, and 2 minus 3 is -1. 2 times 2 is 4. 4 minus 3 is +1. Perfect. Okay, so we're going to plot some points here. We're going to take these, and these are solutions. So that means they're kind of a relationship, that a -2 goes with a -7. -2 doesn't go with any other number other than a -7. So you have this point of -2, -7. You have this point of -1, -5. You have a 0, -3. You have a 1, -1, and a 2, 1. So that's what I'm plotting. Okay, so those are my x's and y's, so I can just write them as a coordinate if I want to. So if there's a pattern here, there should definitely be a pattern on your graph. There's a visual representation of it. So it says we're going to graph the equations above using the table. So here's our equation of 2x minus 3. And if we plot this point of -2, -7, 1, 2, 5, 6, 7, there's a point, -1, -5, so 1, 2, 3, 4, 5, so we went back 1, down 1, 0, -3, 1, -1, and then a 2, +1. So if you look at the points, there's definitely a pattern. It's a nice straight line, and I can just connect the dots. And that's what that graph for this equation looks like. Okay, now there's definitely a faster, more efficient way to do this, but we're at the beginning stages of this. Okay, just kind of really showing what it means to put this all together. Okay, so we're gonna do the same thing on this one. It's gonna be a different equation, so a different line. First thing that I'm gonna do though, to kind of make this math a little bit easier, is I'm gonna take this 2x and I'm gonna shift it over to the other side by subtracting it. Okay, so that gets me my y by itself. It's just easier to plug in and do the math typically if we get the y by itself than leaving it like this. So these are not like terms. So it's going to be a negative 2x plus 7, and I'll make a table. So I'm going to plug in the same 5, negative 2, negative 1, 0, 1, and 2. And we're going to do the same thing. We just have a different equation. So we have a negative 2 times negative 2 plus 7. We have a negative 2 times negative 1 plus 7. We have a negative 2 times 0 plus 7, negative 2 times 1 plus 7, and a negative 2 times 2 plus 7. And those are our inputs. Let's see what our outputs become once we do this math. So we have a 2 times a negative 2 is a positive 4. 4 plus 7 is 11. This is a positive 2 plus 7 is a 9. This is 0 plus 7 is 7. Okay, and there's definitely a pattern that seems to be happening. We're going down 2, down 2. So it should be a 5 and it should be a 3. So let's double check. So negative 2 times 1 is negative 2 plus 7 is 5. This is negative 4 plus 7 is 3. Great. So our equation is, this is kind of what we manipulated it into. But technically, this is an equivalent version of this. But if we turn it into that, we are graphing negative 2, 1, 2, 3, 4, positive 11. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, ooh, 11. Perfect. And then negative 2, 9 would be 2 lower, and then 7, and then 5, and then 3. Okay, and so then that is what that looks like. So remember that this line represents solutions. That if you were to take that negative 1 and that 9 and plug it into the original, it would work. Basically, you're looking for x and y combinations that add up to 7. So if you plug in 0 here and you plug in 7 there, 2 times 0 plus 7 is 7. If you put a 1 and a 5, 2 times 1 is 2, plus the 5 is 7. So that's what the line represents. It represents solutions. Every one of these points, even if you continued on, every one of those points, if you were to figure out the pattern down here and use a coordinate down here and plug in the x and plug in the y, it should add up to 7. In fact, even fractions. Any of these points in between could be fractions, like that would be a fraction, could be a half. If you could plug in fractions, but a certain combination would work for this. So if you plug in a specific x with a specific y, they add up to 7, fractions, decimals included. That's why we connect the dots. Okay, so that line represents the infinite amount of solutions that work. All the other points that are not on the line represent combinations that don't add up to 7. Like if you did a 1 and a 1, that coordinate right there is not on the line because it doesn't add up to 7. Okay, so these points are solutions. These points are solutions to this equation. Okay, now this is a long way to do it, and there's definitely a more efficient way to do it that we'll get to, but this is just kind of building, here's the idea of what we got going on.